Good morning, everyone.
Good morning.
Good morning. Okay, so beta, today we are going. Good morning. Good morning. Today we are going to start off with the celestial navigation, and the first topic which we are going to cover is the celestial sphere and different systems of reference on the celestial sphere, which will take us to the concept of PZX triangle. So this is what we are going to do now. So let's get into the presentation. Let me set it up. Before going ahead, any doubts or queries in your mind?
No, sir.
Okay, great. So let's go ahead. Let's set up the presentation. In this presentation, we are going to understand the rational horizon diagram. The rational horizon diagram is a very, very important concept as far as celestial navigation is concerned. Most of the problems in celestial navigation can be easily solved or can be easily understood using this concept of the rational horizon diagram. Now, when we are understanding this rational horizon diagram, we will discuss about two different systems of reference which we use to identify celestial bodies. One is known as the equinoctial system of reference, and the second one is known as horizon system of reference. We will understand the concept of celestial sphere, celestial meridians, celestial equator, or the equinoctial, all these things one by one. And once we are comfortable about these concepts, we will be able to easily understand the concept of what we call as a PZX triangle. So PZX triangle is very widely used in many concepts of celestial navigation. So this topic basically forms the basis, the foundation of your understanding of celestial navigation. So let's start to understand these concepts one by one. Now we first move on to the concept of the celestial sphere. Now to understand the celestial sphere, let's make a diagram here. Let's assume that this circle, what we see on the screen, represents the Earth. So we have the Earth on the screen now. Now on Earth, we have our reference system, which is based on the equator and the poles. We know the Earth is rotating about its axis, completing one rotation in 1 day. And these axes, they pass through the Earth's poles, the Earth's geographic pole, which are North Pole and the South Pole. So let's mark off the poles in this diagram. The North Pole is here in this particular location. You can see it is represented by NP, and the South Pole is here in this particular location, and you can see it represented by SP. So we have both the poles of the Earth marked on our diagram. Now let's show the equator also. Now we know equator is a great circle on the surface of the Earth, exactly midway between the two poles. So you can now see the equator in the diagram. So I have marked the equator, The Earth is shown at a slightly tilted angle. So that is just to make a clear diagram, which is easy to understand. So we have the equator marked in the diagram. It is shown here labeled as equator on our plot. Now, once we have the Earth, the poles, and the equator in our diagram, we can now proceed to understand the celestial sphere. Now, you see this bigger red color circle in the diagram. This bigger red color circle represents the celestial sphere. Now, to define any sphere, we need to specify what is the center of the sphere and what is the radius of the sphere. So we will specify the center as well as the radius of the celestial sphere also. As you can see from the diagram, the center of the celestial sphere is the same as the center of the Earth. So Earth and celestial sphere are both concentric spheres. The center of the celestial sphere is same as the center of the Earth. Now coming to the radius of the celestial sphere is assumed to be infinite radius. So the celestial sphere is a sphere whose center is same as the center of the Earth, and it has infinite radius. Now, what is the purpose or use of this celestial sphere? Now, this celestial sphere is very, very helpful in solving celestial navigation problems. Now, it is an imaginary sphere. It does not exist in reality. We have assumed this sphere so that we are able to easily calculate the required parameters or the required items which we need, which is basically the position of the ship. So that is what we are interested in. So involving the celestial bodies, the sun, the stars, planet, and the moon, all these 4 different celestial bodies, we have the sun, we have the moon, we have various stars, and we have 4 planets which are used for celestial navigation. So involving these objects and finding our position on the surface of Earth, fixing up the ship's position, was made possible only with the assumption of this celestial sphere. As I told you, this is an imaginary sphere. We have assumed it. Now, how does it help us to get the items or solve the questions which we need? How does it help us to find the position? Now, this celestial sphere, as I told you, it is assumed, it's an imaginary sphere. We consider that all the celestial bodies are situated on the surface of the celestial sphere. Whether it is the sun or the stars or the planets or the moon, we consider all of them to be situated on the celestial sphere. Now, once these bodies are considered to be situated on the celestial sphere, we are able to use our knowledge, formulas related to spherical trigonometry to solve them. So we know spherical trigonometry is the branch of trigonometry which works on the surface of a sphere, on the 3D curved surface of a sphere. We have a few important formulas. Just to name, cosine formula and Napier rule are a very important relations or formula in spherical trigonometry. So once you consider all the celestial bodies to be situated on the celestial sphere, we can easily use these formula to calculate the required items which we need for our purpose, or we can use it to fix up the position of the ship. So that was the advantage or the purpose of imagining this celestial sphere. Now, just like we have references on the surface of Earth to fix up the observer's position. Similarly, we also have some references on the celestial sphere to specify or fix up the position of the celestial bodies. On the surface of Earth, the references which we use are the equator. We can specify the latitude of a position using the equator. It tells us how much, the latitude basically tells us how much north or south of the equator a particular position is. And the second reference which we use are the meridians. Meridians are semi-great circles passing from the poles, North Pole and the South Pole. We have the Greenwich meridian as our reference meridian, and we have the meridians running 180 degrees east and west of the Greenwich meridian. So they give us a reference to calculate or find out the longitude of a particular position. So this is the reference what we use on the Earth's surface, the latitude and the longitude. Now, how to specify the position of celestial bodies on the celestial sphere? So for this, we have made some references, and they are very much similar to the references on Earth. So let us now see the references which we have on the celestial sphere. Now, we know that the Earth rotates on its axis, completing one rotation in 24 hours. Now, these axes pass through the poles, the North Pole and the South Pole. So let us mark this axis of the Earth in this diagram. And let us extend this axis to the celestial sphere. So you can see this dotted line. This dotted line basically represents the axis around which the Earth rotates. The points at which it cuts the Earth's surface are the North Pole and the South Pole. They are already marked in the diagram. Now, if you extend this axis of the Earth, or you project them up to the celestial sphere, you see the axis of the Earth projected onto the celestial sphere or extended to the celestial sphere meets the celestial sphere at this particular place. Now, this is known as North Celestial Pole, represented by NCP, which stands for the North Celestial Pole. Similarly, the axis of the Earth extended towards the South Pole of the Earth meets the celestial sphere at this particular location, and this is known as the South Celestial Pole. So you have the South Celestial Pole marked on the diagram as SCP. So these are the two celestial poles which we use as our reference. Now, exactly same as we have the equator on the surface of Earth, equator is a great circle which is equidistant and exactly midway between both the poles, the North Pole and the South Pole. Now, in an exact same manner, a great circle on the celestial sphere exactly midway or equidistant from the North Celestial Pole and the South Celestial Pole is known as the celestial equator. So you can see resemblance in the names. We have it as a equator on the Earth's surface, and when it goes to the celestial sphere, we call it celestial equator. Other name which is more common in navigation terms is the equinoctial. So we also call it the equinoctial. The north and south poles, when they are projected onto the celestial sphere, are known as the celestial poles. The equator, when it is projected onto the celestial sphere, is known as the equinoctial. So let us show the equinoctial also in the diagram now. So you can see this red color great circle, which is located on the celestial sphere, exactly midway between the North Celestial Pole and the South Celestial Pole. This is the equinoctial. So you can see it labeled in the diagram. Now you can also understand equinoctial from a different perspective. If you extend the plane of the equator outwards, the plane of the equator is extended outwards, or you can say if the equator is projected onto the celestial sphere. So you can assume that there is a light source at the center of the earth, and the equator is casting its shadow. A shadow is being cast on the celestial sphere, and that is also known as a projection. So this shadow, wherever it hits the celestial sphere, forms the great circle which we know as equinoctial. So we have the equinoctial in the diagram, we have the North Celestial Pole and the South Celestial Pole in our diagram. These are used as reference points to specify the position of any celestial body on the celestial sphere. Now, how do we use it as references? This is also very similar to what we do on Earth. On Earth, we represent a position using its latitude and longitude. Now, latitude is referenced to the equator. The latitude of a place basically tells us how much north or how much south of the equator a particular position is. Exactly in the same way we use the equinoctial. We first find out whatever celestial body we want to specify, how much north or how much south of the equinoctial that particular body is. And on celestial sphere, we call it as the declination of the body. So the job of latitude on the surface of Earth is done by the declination on the celestial sphere. So if you have the declination of any celestial body, it immediately tells you how much north or how much south of the equinoctial that particular body is. So that's how we use the equinoctial as our reference. Now, for the longitude of any place on the surface of Earth, we use the meridian of Greenwich. We use the Greenwich meridian as our reference meridian, and we find out how much east or how much west of the Greenwich meridian that particular body is. Now, on the celestial sphere, we have two references. One is exactly similar to Greenwich, which is the celestial meridian of Greenwich. What is the celestial meridian? Now, a celestial meridian is very much similar to the meridian which we have on the Earth's surface. The meridians are semi-great circles joining both the poles of the Earth, the North Pole and the South Pole. Now, in the same way, a celestial meridian is also a semi-great circle on the celestial sphere joining both the celestial poles. So you can see a green color dotted line on the screen now, highlighted by the laser pointer. So this dotted green line is a great circle which is passing from both the celestial pole, the north and south celestial poles. Now this is what we call as a celestial meridian. We can have infinite number of great circles passing from both these poles, as these are diametrically opposite points. Now, if we project the meridian of Greenwich onto the celestial sphere, wherever it projects or falls, that is called as the celestial meridian of Greenwich. Now, celestial meridian of Greenwich is used as a reference to specify the position of a body, but we do not use the longitudes on the celestial sphere. What we use on the celestial sphere is GHA, Greenwich R angle. So Greenwich R angle is measured with reference to this celestial meridian of Greenwich, and it is measured in the westerly direction. So just as we have the Greenwich meridian as a reference on the surface of Earth, we have the celestial meridian of Greenwich on the celestial sphere as a reference to specify the position of any celestial body. So if we get the declination and the GHA of any particular celestial body, we will be able to fix up that body's position on the celestial sphere. The declination will tell us how much north or south of the equinoctial that body is, and the GHA, Greenwich hour angle, will tell us how much west of the celestial meridian of Greenwich that particular body is. So it will specify the position on the celestial sphere. Now, a second reference is also used in terms of specifying the meridian of the body. The second reference is used with respect to a particular position on the celestial sphere, which is known as first point of Aries. Now, later on, I will discuss with you the concept of ecliptic. Ecliptic is basically the path of the sun projected on the celestial sphere. Now, this ecliptic cuts the equinoctial at two places, and these places are known as first point of Aries and first point of Libra. So if you use this first point of Aries as your reference, and you measure the angle westwards of this first point of Aries, it is known as SHA, sidereal hour angle. So these are the two references which we use to specify a body. Either we use the GHA, measured from the celestial meridian of Greenwich, or we use the SHA, sidereal hour angle, which is measured from the celestial meridian of first point of Aries. So this is the equinoctial system of reference on the celestial sphere. Important thing to keep in your mind is we should be clear about the concept of equinoctial. We should be clear about the concept of what a celestial meridian is, and with it, we will be able to easily understand the concept of declination and GHA or SHA. So this is the equinoctial system of reference on the celestial sphere. Beta, any doubts up to here?
Sir, GHA or SHA make the difference.
Okay, beta. Beta, both GHA and SHA are measured as angle at the pole. So you see the pole here, the north celestial pole or the south celestial pole, any one of them. Both the GHA and SHA is measured as a angle at the pole contained between, in case of GHA, the reference meridian which is taken is the celestial meridian of Greenwich. Means if you project the Greenwich meridian onto the celestial sphere, it will give you the celestial meridian of Greenwich. So from the celestial meridian of Greenwich, how much west that particular body is, that is what is GHA. Is it clear, beta?
Okay, sir.
And if you take your reference not as the Greenwich meridian, but as the meridian of first point of Aries. So if you take your reference from there, this angle, how much west the body is from celestial meridian of Aries, will give you the SHA, sidereal hour angle.
Okay, sir.
Okay. So shall we move on to the horizon system now, beta?
Yes, sir.
Okay, all right. Now, having understood the concept of celestial sphere as well as the equinoctial system of reference, Let's move on to our second very important system of reference, which is known as the horizon system of reference. So this is the second reference system which we use to specify the position of any celestial body on the celestial sphere. The position can be specified by the equinoctial system, or it can be specified by using the horizon system also. And the rational horizon, which I talked about, the rational horizon diagram, is basically a combination of both these systems. So let us now concentrate our attention towards the horizon system. The diagram which you see right now on the screen is exactly the same diagram which we discussed in the equinoctial system. You can see the Earth in the center. You have the North Pole and the South Pole of the Earth. You see the equator marked here, and you see the axis of the Earth projected onto the celestial sphere, meeting at North Celestial Pole and the South Celestial Pole. Then you have the semi-great circle joining both the celestial poles. The green color semi-great circle which you see, that is the celestial meridian. And you see the equator projected onto the celestial sphere, giving us the equinoctial. Chetan beta, can you switch off your mic? Okay. So all these are the same items which we discussed in the equinoctial system of reference. So we are now going to add on the horizon system in this particular diagram only, so that we understand the concept, or we are able to combine them easily one by one. Now this horizon system of reference is dependent upon the position of the observer, or the position of the ship, where the observer is. If the observer changes its position, the horizon system references or coordinates also change. It is entirely based on the position of the observer. If you see the equinoctial system which we discussed earlier, for which you see all the references in this diagram, it has got nothing to do with the position of the observer. It is independent of the observer's position. The observer could be anywhere on the Earth's surface. The equinoctial is going to stay in this location only. The North Celestial Pole, the South Celestial Pole are going to stay at this particular location only. So the equinoctial system was totally independent of the observer's position. Now the horizon system is dependent on the position of the observer. So let us first of all specify the observer's position on the surface of Earth. And basis that position, we will be able to find out the references used in the horizon system. So we have the observer at this particular location on the Earth surface, highlighted by the laser pointer. This is where the observer is. It is represented by O. You can see the observer written here in the diagram. Now what we are going to do is, from the center of the Earth, I'm going to draw a line up to the observer's position, and I'm going to extend that line on both the sides so that it goes and meets the celestial sphere. So starting from the center of the Earth, I'm drawing a line which passes from the observer's position and meets the celestial sphere at this particular location. And the same line, if it is extended on the opposite side, you will see it will go and meet the celestial sphere at this particular location. Now these 2 points where this line meets the celestial sphere are our references for the horizon system. This line passing from the observer's position meets the celestial sphere at a particular point which we call as the zenith of the observer. So if you look carefully, you can also see that this zenith is going to be the point on the celestial sphere which is directly overhead of the observer. So if you look up to the sky, exactly upwards, totally upright in the middle of the sky, if you see overhead of you, the point which is there is the zenith of the observer. And this line extended on the opposite side, it meets the celestial sphere at a certain point, which is called as the nadir of the observer. So zenith and the nadir, our two references for horizon system. So I'm repeating once again. If you draw a line from the center of Earth, passing from the position of the observer, extended up to the celestial sphere, the point where it goes and meets is known as the zenith of the observer. And the point diametrically opposite to it, or where the line extended in the opposite direction goes and meets the celestial sphere, is known as the nadir. Now, we have the zenith and we have the nadir represented on the celestial sphere. Now we are going to draw what we call as the rational horizon. Now, rational horizon is a great circle on the celestial sphere. A great circle on the celestial sphere exactly midway between the zenith and the nadir. So let's mark it in the diagram. You can see this blue color great circle represented in the diagram as the equinoctial. Sorry, as the rational horizon. My mistake. So rational horizon is a great circle on the celestial sphere exactly midway between the zenith and the nadir. You can see the relationship is quite similar to what we had between the celestial poles and the equinoctial. Equinoctial was located exactly midway between the celestial poles. Exactly in the same fashion, rational horizon is situated exactly midway between the zenith and the nadir of the observer. It can be defined in another wording, that is, a rational horizon is a great circle on the celestial sphere, every point on which is 90 degrees away from the zenith as well as the nadir of the observer. So this rational horizon is a very important reference for us as far as the horizon system is concerned. So we use the rational horizon as our reference, and we use these 2 points, the zenith and the nadir, as our references. Now, if you look carefully, the rational horizon basically divides the celestial sphere into 2 parts. That part of the celestial sphere which is above the rational horizon, you see, this particular part of the celestial sphere which is above the rational horizon is what will be visible to this particular observer. When he looks at the sky, he will be able to see that part of the celestial sphere which is above the rational horizon. To put it broadly, so that part of the celestial sphere which is above the rational horizon will be visible to the observer. And to put it broadly, that part of the celestial sphere which is below the rational horizon of the observer will not be visible to the observer. So this part is going to go below his horizon and it will not be visible to him. Now let's go forward from these 2 references. We have the rational horizon and we have the zenith and the nadir. Now, let's try to specify a sense of directions basis the rational horizon. Now, if you have the observer at this particular location on the Earth surface, and let us say this observer is looking at the sky in the northerly direction, so he will have this North Pole exactly front of him. Let us say you are on a ship which is moving on 000 course. You are steering true north 000. If you look towards the northern part of the sky, if you look right ahead, you will be able to see the North Celestial Pole or the Polaris, the pole star. So this North Celestial Pole or the direction of the pole star, if you bring it down to the rational horizon, this gives you the north point on the observer's horizon. So if you are on a ship which is steering 000, you can see the Polaris or the pole star. Now, if you draw a vertical line coming vertically down from the pole star, the point wherever it hits the horizon, it represents the true north direction, 000 direction. Now, exactly opposite to it. So for this particular observer, he looks at the celestial pole. The pole is here. He comes vertically down below that pole, and wherever it touches the horizon, that is the north point for him. Exactly opposite to it, exactly opposite direction. That means this particular direction will be the south direction. So let's represent it by a S. The north direction is represented by N, and exactly opposite to it, we have the south direction. Now the angle between both these directions will be 180 degrees. They are diametrically opposite, the north and the south. So this is our observer looking toward this side. He is looking at true north or the north point of his horizon. Now, if he goes 90 degrees to the right of the north, so if you go towards the right side from north, this is the right side. And if you go 90 degrees away on the right side, this point which you see on the horizon is the east point. You can visualize it on the ship also. Let us say you are on a ship which is steering 000. You are looking out of the bridge window. You are looking right ahead. The point which you see right ahead is the north point on your horizon. Now from that point, if you go towards the right or towards your starboard side for this particular ship, if you go to the right by 90 degrees, this is the easterly direction for you, or the 090 direction for you. So exactly same thing is represented here in 3D. The observer is here looking at the north direction, which is at this particular location. From north, going in the right direction by 90 degrees. This point, reference point, which we have on the horizon is the east point. Now, if you move towards the left side, from the north point, starting from the north point, if you move towards the left side, if you move towards the left, 90 degrees away from the north point, wherever you will reach, is the west direction on your horizon. So these points which you see here, north, east, south, and west, represents the directions on the rational horizon. Exactly below the North Celestial Pole or the Polaris is the north point. And once you identify the north point, you will be able to correlate or identify exactly opposite to it. That point is south. From the north, you go 90 degrees to the right, you will find the easterly point. And from the north, you go 90 degrees to the left, you will find the westerly point. Now, in this particular diagram, this is a 3D diagram. Now we have tried to show the full complete celestial sphere in 3D on a plane surface. We are trying to show a 3D object on a 2D surface. So that could be a little bit confusing, but when you are looking at the celestial sphere, You see this westerly point which you see, the west direction point, is the part of the celestial sphere which is towards us, or this part is towards the observer, and the east point which you see, it is on the far side of the celestial sphere which is opposite to us. So east point is on the far side of the celestial sphere, or on the other side of the celestial sphere, which is behind the screen you are looking at. And the westerly point is towards the screen, or the westerly point is towards you. When you are looking at the screen, the westerly part of the celestial sphere is towards you. So that's how this diagram is made. So we have these 4 reference points on the celestial sphere. Now let's go to another very important reference on the horizon system, which is called as a vertical circle. So what is this vertical circle? To understand this vertical circle, let us assume a celestial body. Let us assume there is a star which is visible to the observer in the sky. So let's mark this star in our diagram. You can see a particular star here in the diagram, which represents a celestial object. Now, to show or represent the vertical circle of this particular body, let me show you in the diagram. Let's mark this body as X. So we have the celestial body, the red color star which you see, labeled as X. Now let me draw the vertical circle passing through this particular celestial body. So you see this red color semicircle shown in the diagram is the vertical circle of this particular celestial body, this particular star. So once you see it in the diagram, now it will be very easy to understand what a vertical circle is. A vertical circle is a semi-great circle on the celestial sphere passing from the zenith and the nadir of the observer. So this is also very similar to the celestial meridians you see. The celestial meridians were semi-great circles passing from both the poles, the north celestial pole and the south celestial pole. Now in the same fashion, a vertical circle is a semi-great circle on the celestial sphere passing from the zenith and the nadir. Now zenith and nadir being diametrically opposite points, an infinite number of vertical circles can pass through them. Now what we are interested in is in the vertical circle passing through the celestial body. So in this particular case, when we have a celestial body, that is this red color star X, the vertical circle passing through this body is this red color semi-great circle. So vertical circles, I'm repeating once again, vertical circles are semi-great circles passing through the zenith and the nadir of the observer. And for our reference, we are interested in the vertical circle, which is passing from the celestial body, which we are using for observation or sight taking. Now, once we have understood the concept of a vertical circle, we can now move on to a very, very important concept of the true altitude of a celestial body. I told you before we started off on this horizon system that this is a reference system used to specify the position of the celestial body. So how do we specify the position? Now, one of the terms which is used to specify the position of the body is the true altitude of the body. Now, true altitude basically tells us how much above the horizon a particular body is. So Let us see the true altitude in this particular diagram now. You see this red color dotted line represents the vertical circle passing from the body. Now this vertical circle is passing from the body. This vertical circle is also crossing the rational horizon at this particular point. Let's call this point as H. So you can see this H point shown in the diagram. This is the point where the vertical circle crosses the rational horizon. Now, if you measure the arc of the vertical circle contained between the rational horizon and the celestial body, the arc of the vertical circle contained between the rational horizon and the center of the celestial body is known as its true altitude. Let me highlight this in the diagram. So you see this maroon highlighted arc from H to X. H is the point on the rational horizon and X is the center of the celestial body. So HX, the maroon highlighted arc, is the true altitude of this particular celestial body. So again, let me repeat the definition. You will be able to understand it now. The arc of the vertical circle contained between the equinoctial and the center of the celestial body, which is highlighted also by the laser pointer right now. Arc of the vertical circle contained between the rational horizon and the center of the celestial body is known as its true altitude. So you can see the true altitude labeled in the diagram now. We have the true altitude represented by HX, Hotel X-ray. Now, once we have understood the concept of true altitude, it will be very easy to understand another term, which is the true zenith distance. Now you see, if you look at this vertical circle, at the rational horizon, it crosses the horizon at point H. Then if you move towards the body at point X, this vertical circle reaches to the center of the body. Now, if you go further upwards from the body up to the zenith, now this arc of the vertical circle contained between the zenith and the center of the celestial body. Let me highlight it in the diagram. The green color arc which you see is the true zenith distance of the celestial body. So the definition, arc of the vertical circle contained between the zenith and the center of the celestial body is known as its true zenith distance. So you can see the TZD as green color arc highlighted as a part of the vertical circle. Now we know that from the zenith, if you go up to the rational horizon along any vertical circle, from the zenith to the rational horizon, the distance is 90 degrees. In fact, that is in the definition of the rational horizon also. It's a great circle on the celestial sphere, every point on which is 90 degrees away from the zenith as well as the nadir of the observer. So from the zenith, Z point, to H, which is on the rational horizon, this total arc is 90 degrees arc. And we know from H to X is the true altitude of the body. So it immediately tells us that the true zenith distance of the body, represented by this green color arc or ZX, will be equal to 90 minus true altitude. So you can see it labeled in the diagram, the true zenith distance of the body equal to 90 minus true altitude. So true zenith distance is equal to 90 minus true altitude. Or in other words, you can say the true zenith distance plus the true altitude of a body always add up to 90 degrees. So we have understood the concept of true altitude now. We have also understood the concept of true zenith distance now. Very, very important concept from the horizon system point of view. So all the things, new things which we discussed in the horizon system, they have been added up in the same diagram. The diagram now shows you both the systems. You see the equinoctial system also. You see the horizon system also. You see the references from the horizon system as well as the equinoctial system. Okay, so beta, this was the important concept of both these reference systems. We are almost done for this session now. I wanted to complete the explanation. So you can have a good look at this. If you want, you can take a screenshot. And whatever doubts you have, I will cover them up in the next class.
Okay, sir.
Okay. So I'll show you this diagram again once we meet in the next class. So let's close out the presentation now. So this was our introduction to celestial navigation. So next lecture when we meet now, we will see the PZX triangle, and then we will proceed ahead to different topics which involve the use of PZX triangle for solving questions. So over the weekend, I would request you guys to get your nautical almanacs out and get a little bit familiarized with the nautical almanac. We have used them during second mates also. So get little bit familiarized with the nautical almanac. What is given there, sun, star, planet, moon, their GHA, declination. एक बार daily pages को खोल के देखो. So get familiarized with it because now in the coming lectures we will be using the almanac. So you can look at the almanac. You can also look at altitude corrections. True altitude is obtained by applying the corrections to the sextant altitude. So just look at those corrections, just revise them once, and that should prepare you for the coming lectures. So that's your homework for the weekend. So see you in the next class. Till then, bye bye.
Thank you, sir.
Thank you, sir.
Sir,
Thank
your
you,
best
beta.
homework for the weekend.
Thank you, sir. Say again, beta.
सर अभी तक इतने वीकेंड्स में से ये बेस्ट होमवर्क है.
Okay, good. बट इससे अगले वीकेंड पे लोड बढ़ेगा, होमवर्क मिलेगा.
Yes.
ओके, ऑल राइट. ठीक है बेटा, बाय बाय, सी यू.